Yesterday, I have completed the portion of turbine which is given supposed to be shown in your introductory lectures of this power plant engineering. I have told you that the by the term turbine is a prime mover, and by the term prime mover means it is a setup or device which converts the natural energy into useful power to mankind. These turbines here in case of a thermal power plant or power plant in thermal power plants converts the heat energy of vapors into the rotation or torque or torsional energy of the turbine outlet or turbine shaft. There are different type of turbines. There are different type of turbine depend entirely on the type of application and required for the for the general for the concerned industry or concerned outputs. It can be condensed, non-condensing, depending on whether the back pressure is low or equal to the atmospheric pressure. There is a term known as back pressure. Back pressure means what? Turbine from is receives energy to a high pressure, high energy, high temperature steam in the form of high pressure and high temperature steam, and through nozzle, this high pressure is converted to uh, high velocity steam, which is in fact creating an impact energy to the turbine or to the turbine rotor by impinging on the turbine blades and various turbine blades. Now, the high temperature due to at the time of transforming is lowered, and it can be equal to the atmosphere or even it can be less than to the atmospheric pressure. Thus, the part, the steam vapor after coming out of the turbine may be totally converted into liquid water or a mixture of the same. There are different type of turbines which I have told you, and the turbine is maybe straight flow and with or without straight flow turbine for a large unit without any reheat or without any low pressure turbine itself. Now, now the the straight flow turbine for a large time without repeat, the steam may extend through initial section and then exhaust to another turbine itself. Uh, so there are other turbines which is defined as high pressure turbine, intermediate pressure turbine, and low pressure turbines. This means a turbine uh, after expand the steam input steams after expanding through the turbine of a high pressure turbine may be reheated again to gain this temperature and go to the intermediate pressure turbine. Then it can be either reheated or not reheated but sent to the directly to the low pressure turbine, and from low pressure turbine it always releases the condenser itself, where it is by the action of the cold by the action of the cold liquid, it's takes away the heat from the turbine from the steam and water mixture and convert it into water itself. Now what happens there? This that can be all these turbines, intermediate, high pressure, low pressure, can be fitted on the same shaft, or sometimes it's supposed to be, thus it is supposed to be the rotated or the RPM of the salt shaft is the same. Generally around 3600 RPM is created for the proper running of the converter itself. But there are certain instances here where we use different shafts to use the mount the turbines of low pressure, high pressure on different shafts, not on the shaft shafts. Thus, in order to reduce the RPM to a certain extent as per your requirement. Well, this is different way we have distributed the turbine process, and for the initial stage, more or less, it is okay, it is sufficient. And turbines have most important parts are the blade itself, and sometimes the turbines are specified in terms of or designated in a certain term like say TC4F30, like It example is tandem compound. TC means tandem compound, means it is at tandem with shaft is a tandem with each other. Means on the same shaft, all the low pressure intermediate and high pressure turbines plates are fixed. And tandem compound is TC, 4 floor two plates, 4F is two plates, and 30 two stages, low pressure and high pressure, and 30 means 6.2 centimeter last stage blade length, means the low pressure turbine blade length, and CC is 2F23 terms indicates that there is a cross compound CC having one double flow 2F low pressure turbine with 23 inches, 23 or 58.4 millimeter last stage blade length. Now flow through the nozzles. The nozzle is a duct by which flowing. Now let us discuss what is the nozzle itself. It is not nozzle is not a blade or not a wheel or anything like this. It is nothing but a duct. Duct means a vessel or a passage through which is used for transferring the transferring vapor at high heat and high temperature and high pressure, and during the at the process of transferring, the pressure is being reduced and velocity of the fluid out at the outlet is being increased. Now here what is doing here, velocity is created or velocity of the fluid is increased at the expense of the pressure drop of the concerned fluid itself. A duct which decreases the velocity of fluid and causes a corresponding rise in pressure is called diffuser. Now there are the ducts which also does the exactly opposite function. They reduces the velocity of the flow and thus increasing the pressure at the outlet of the fluid it is carrying. This is called diffuser, and the same duct. So the same duct may be either a nozzle or diffuser. There are two terms here for the duct itself. One is a nozzle, another is a diffuser. In the nozzle, we are increasing the velocity of the fluid at the expense of the reducing the pressure, and the diffuser, we are increasing the pressure of the fluid concerned and at the expense of reducing the its velocity. But a sink tap can be of either ways. In certain portion, it is nozzle, means its cross-section area is reduced and certain reduced from the initial to final, and certain portion its cross-section area is again increased from the increase from the minimum at the inlet and maximum at the outlet itself. Now, so depend on the end condition we are required. If the cross-section of the barb decreases continuously from inlet to, just 1 second. Now, now, if the cross-section of the ducts remains continuously changes or decreases continuously from inlet to exit. It is called, its draft is said to is divergent. If the cross section of the initially decreases and then increases, the draft is said called convergent and divergent. Initially, initially decreases, then finally increases. So first, it is convergent, it is going inside, and this divergent when going out, opening outside. The minimum cross section of the draft is generally called throat, where this change takes this type of draft, which is changing its cross section area somewhere from bigger to smaller and smaller, then smaller to bigger. At the position, the cross section where the draft is exactly, which is a minimum cross section of draft, is defined as the throat of the draft itself. A fluid is said to be compressible if the density changes with the change of pressure. Means if we can reduce the volume of the fluid by applying pressure, then it is compressible fluid. And if you cannot change the volume as a whole, or if you cannot change the volume, it is incompressible fluid. Or if by applying external pressure, if the density increases of the fluid, it is called compressible. And by applying pressure, if density is not changing, then it is called external fluid. And it is called incompressible. Now here, the fluids we are using is mainly water and vapor, and water vapor, water and water vapor. So all the gases or gaseous substances like water vapor is compressible because by applying high pressure, its density can be increased. But all the liquids like water is generally incompressible, which is its density cannot be changed by applying high pressure itself. Now, what is the need of the condenser itself? Need of the condensers. A condenser where the exhaust stream from the turbine is condensed operates at a pressure lower than the atmosphere. A condenser, what is condenser? Condenser, we absorb the exhaust stream from the turbine and it condenses and converted it into liquid water at a pressure lower than the atmosphere, comparatively lower than the atmospheric pressure. So, where this condenser is generally uh, uses the flow of say, river water or some other cold sources of water which flows through the surroundings of the condenser and reduces the temperature and ultimately may convert the liquid water into moisture into liquid water itself. Now, really two objects of using a condenser in the steam plant. There are two specific purposes. What are they? To reduce the turbine exhaust pressure. Turbine exhaust pressure, the turbine is receiving the pressure at high velocity and low pressure, and still it can exhaust this vapor at the atmospheric pressure itself. But this to reduce the turbine pressure, exhaust pressure as it increases specific output of the turbine, if we can reduce turbine pressure comparatively more at the expense of increasing the specific output of the turbine, then this thing means uh, if you convert the whole pressure energy into the velocity or kinetic energy of the turbine, it will give us more amount of work to the more amount of output work to the turbine, and which will more work output work to the turbine, and which will give increase the efficiency of the turbine itself. Now, the circulating cooling water temperature is always low enough, say around 30 degrees centigrade, it creates a low back pressure. Means generally what we do is for the sake of economy, we use the water as the cooling agent of the condenser, but the water is kept around the more or less natural temperature of a particular place, around say around 30 degrees centigrade itself. Now, if we do it, it will create a low back pressure, means vacuum for the turbine. Low pressure which creates a back pressure sometimes, reduces less than the outside surrounding atmospheric pressure of the turbine. This pressure generally equals to the saturation pressure corresponding to the condensing temperature, steam temperature itself, say 0.074 bar at 40 degrees centigrade, what is shown in this TS diagram of the vapor itself. This is T and this is the psychometric curve, and the turbine is here. Now, the condensing temperature, say 0.074 bar at 40 degrees centigrade, which is in turn a function of the cooling water temperature itself. At is 40 degrees, this is the at the temperature of the vapor at the outlet of the outlet of the condenser itself at 0.74 bars. It depends on, there will be pressure line if you go through the psychometric chart of this for vapor. There will be pressure line equal to 0.74 bar, 0.74 bar at 40 degrees centigrade. Actually, this is in terms a function of the cooling water temperature, which is a term is a function, means output or backing pressure or backup pressure of the turbine is the cooling temperature, depends on the cooling temperature, water temperature itself. That enthalpy of the enthalpy drop or turbine work per unit pressure drop is much greater than the low end at the high pressure of the turbine itself. The enthalpy means the heat energy, drop of heat energy or turbine work per unit pressure drop at much greater than the low end than at the high pressure at a turbine itself. So at the condenser, leaving the back pressure, say point atmospheric pressure 1.03 to 0.074, with this 0.074 is less than the atmospheric pressure, one thing, this increases the plant efficiency, means here you are supposed to release it here, or you are supposed to release it here, somewhere here, when the temperature is equal to the when the pressure is equal to the atmospheric pressure. So total output from here to here is more than from here to here. So it increases the power output from in the compressor itself, increases the power output from the turbine itself for a given output and efficiency. Hence, it's impossible to use the lowest possible cooling temperature, but avoid that pressure away from this, and this plant efficiency reduces the steam flow. But hello, hence it is impossible for to use the lowest temperature cooling temperature itself. What happens? This restricts the temperature rise of the cooling tower of the turbine tubes to 5 to 8 degrees centigrade, so that the tube outer surface temperature runs low, remains low, and consequently condensing steam temperature remains is high and vacuum is high. The temperature rise of the cooling water means the cooling tower, and as what we are doing here is a use of the river water for cooling. It can be used as a cooling tower also. To the condenser tube up to 5 to 8 degrees centigrade, so that the tube outer surface remains low and consequently condensing steam temperature remains low and vacuum is remains high. But to recover high quality feed water in the form of condensate and feed it back to the steam generator without any further treatment. So this is without any further treatment, further rectification, purification, anything like this. High quality steam water, feed water in the form of condensate, and it will feed back to the steam generator without any further treatment and without any further much further addition of water itself. As a result, the next up water to replace the water losses as this cycle plan needs to be treated. Now let us go through what is the different type of condenser. There are two broad classes of compressor: direct contact type compressors, hence The condensate and the cooling water directly mix and comes out as a single drum. There are two broad classes of condensers. The direct control contact type condensers. Here, the condensate and cooling water directly mix and comes out as a single drum. Means sometimes you set the the cooling water to the condensate itself, and thus by that cold cooling water will condensate the will cool the condensate, and both at the outlet you will get both of them as a single stream, and you can send it back to the boiler itself. But surface condenser, which most widely used, there are a shell and tube type condenser where two fluids does not come directly in contact with each other, and that heat released by the condensate will absorbed by the walls of the tube into the cooling water conditionally, circulating inside them. Next, let us go to the initials of the hydroelectric power plant. What we know? We know the hydel power plant or hydroelectric power plant. Here we know the energy of water is now utilized to drive the turbine, which in turn turns the generator to produce electricity. Here, the rains falling on the Earth's surface has potential energy, and relative to the oceans, rain falling from the Earth has some huge potential energy which is in relative against the oceans, towards which it flows. All the water comes inside the earth as in the form of rain, which goes to the ocean in a very general sense. Now, all this rain has a very high potential energy as it is falling from a very high temperature of the Earth's surface, and this energy can be converted into shaft work. So, what we are doing in hydraulic plant, there is rain, there is rainwater falling in the earth and going to the ocean. The rainwater has a very high it has a very high potential energy which we converted into useful work in terms of we have a hydraulic turbine. So here the turbine in the what hydroelectric plant use as a prime mover, which converts high potential energy of the rain into useful work to us. To us. Now, as this work energy is converted into shaft work, where the water falls, but what we do exactly, these energies fall into shaft work, this potential energy, but we don't collect the rainwater and uses it to the for converting the shaft water, but we place our whole hydroelectric plant in a near a say falls, where the water falls through a appreciable vertical distance, and this hydroelectric power, that vertical distance which it falls, means very potential energy which is generated by falling from a certain height is naturally converted into the useful work. So hydroelectric power has a naturally renewable energy sources being by P G rho Q H, where P is the hydraulic power in terms of the watts, G is the moment of inertia, 9.81 meter per sec square. Rho is the water density, means 1000 kg per cubic meter, or Q is the heat flow or discharge, is the flow or rate of discharge in cubic meter per second, and H is the height of fall of water and head. Thus, here we are converting the potential energy into useful work by using this equation, where we using the moment of inertia, G into rho is the water density, Q is the flow of discharge in meter cube, H is the height or fall of water of the head. Now, the electrical energy produced in kilowatt hour can be written as just under like this. Now, the electric energy produced in kilowatt hour can be written as under like this. W 9.8 thousand into Q into H into eta into T, where T is the operating time, say 8760 hours per year. Eta is the efficiency of the carbon generator assembly itself, and which varies between zero point 0.5 to zero point 0.9. The power developed in the two development depends on the quantity of flow and height height of fall of the water itself from the form. So time of running the generator per year, efficiency of the turbo generator, height of fall, and the flow of the energy, flow rate of the energy itself is multiplied by 9.1 with the acceleration due to gravity, which is acceleration due to gravity multiplied by 1000, where just to convert the total watt power from watt to kilowatt. And the hydro and water power is important. This is the total equation which you are getting from a hydel power plant itself. The hydro and water power is important not only due to thermal power, just only next to thermal power. If you got 80% production of thermal power, you'll get at least 20% of the total power of the world is being produced by hydroelectric power station, where in our country, it is comparatively less than the other countries like Canada and USA, where we have the high falls which we can use to convert into energy. Now, hydroelectric power becomes less countries like Norway, Switzerland, where hydroelectric power forms almost the total installed capacity. So it is like that Norway, where Switzerland, which is more or less in cloud area, and a lot of falls are available, and they have the energy or technical ability to convert the falls into the useful work itself. Now, advantage of water power. What are the advantages? What are the advantages? Hydro power have some inherent advantages. What is that? Water source is perennially available. Water source is perennially available. No fuel is required that to be burned to generate electricity, and it is termed as white coal. Sometimes it is always available, perennially available, and no fuel is required to burn. It is called white coal. Water passes through the turbine to waste and downstream, produce waste and downstream, and utility remains for irrigation of plants and quenching of the thirst of the people. So the outlet that water is not wasted, but it can be used for some irrigation purpose and also for drinking purpose of everyone. So what is this? Water is available perennially. We don't have to create anything with water. No fuel is required to burn, no additional energy of fuel, and bringing that fuel into proper places in the land side, as well as keeping the high amount of ash stored in the particular places. All these points are not there. So it is also sometimes defined as white fuel, which is have white fuel, which is superior in use for the than our black coal or black fuel. Water passes through the turbine to produce waste, and downstream its impurity depends for irrigation of the plant and quenching the thirst of the people. Well, we are using the used water, but are not wasting it. We are using. You can use for drinking. You can use for irrigation also. The running cost is extremely low because no cost of purchasing the fuel itself. Fuel is available by naturally. There is no cost of transporting the fuel like thermal power plant. There is no cost of preservation of the waste like ashes in ashes like both thermal and power plant itself. But there is no problem with regards to disposal of ash like this. Now, it can be switched off and on very quickly, whereas thermal power plant requires 2 days to function, where it can be moments you can start the plant if your water jet is available. It has much higher life expectancy or it's around 50 years for more and gives high efficiency over a considerable range of flow. It's high efficiency, considerable range. So it is naturally available. Running, there is no running cost, no problem of disposal of ashes or radioactive waste. It can be start and start off very quickly, unlike power plant, thermal or nuclear power plant, which takes few days, at least 2 to 3 days to start during startup and shutdowns. And it has greater life expectancy. It has around 50 years of life, where in thermal power plant mostly have 30 years of life itself. And it gives high efficiency over a considerable range of load. But what are the main disadvantages of power water plant? This water power also have some specific disadvantages. What is that? The hydroelectric projects are capital intensive project with a low rate of return. The hydroelectric projects are capital intensive project with a low rate of return. The annual interest of their capital lost cost is very large. Part of the initial cost of the hydroelectric power is installation. But what is the main problem is the installation. Hydroelectric power plant cannot be installed in a plain land. We have to install in a hill area where you can get the stream jet of a falls itself. So it requires a lot of movement of the equipments from your manufacturing side of the equipments to the installation side of the equipments. All cost improves powers and bringing up the costly and heavy equipments in a high place is also important and complicated affairs. And all these things are not don't have any return, no source of return of any equipment. The annual interest of the capital cost is large part of the initial cost of the hydroelectric power plant. The amount of money we are spending only for installation is much higher than the power plant or nuclear plant itself. The building period means a total setup period of a hydroelectric plant is quite large. The gap between the foundation and completion can be 10 to 15 years, where a normal power plant is being manufactured is from start to end of the installation. It requires more or less 3 to 5 years, but here hydroelectric power plant from start to installation may take from 10 to 15 years, which is quite high. And all this lengthy period involves a considerable amount of input investment of money for running your show or the full installation installation show. The power generations are now dependent on the quantity of water available. It totally depends on the quantity, and which we don't have much influence to change or increase or decrease, which may vary for seasons to season. Some rainy season there is high amount of water, but for summer season there is much limited water, and year to year always the same monsoon is not going on for all year, and human being have no control over the monsoon. It can be more or less or average as per the will of the nature, not of the will of the human being. If the rainfall is also maybe in lack of late or maybe early, and maybe early and maybe inadequate or adequate. So if the rainfall in right time and it is adequate, only then it will get the satisfactory performance of the power plant itself. But these power plants are very far away from the load center, means where this power is being used. It can be installed in a hilly area where you have to use the power in, say, probably hundreds of miles away a town or in a locality or somewhere like this, or in industry like this. Now, such requires very large, such requires a very large, long installation transmission due to delivery of power. Thus, the cost of transmission lines and losses of them are more. The hydroelectric power plants disturb the ecology of the area by way of deforestation, destroying of vegetation, and uprooting people. In a specific place, we have to install the plants. And if there is any long forest, we have to uproot and clear the forest. If there is some inhabitants, you have to clear the inhabitants of the people. All this triggers lot of problem, a lot of money, and lot of resentment among the people concerned. The if the private opinion and the people concerned which are uprooting due to this power plant don't have any interest in the electricity or anything like this strong public opinion again, this power plant is a det- different deterrent factor. It can create a lot of problems of installation as well as in running. The emphasis is now make more small, minimum, and micro hydro power station. Now we are thinking of doing it not a large power plant, by a large hydro power plant, but a mini or mini power plant just to make the power for a limited area for limited people by amount investing less amount of money and spending less amount of time itself. Thus, the all of thinkings may change time to time according to the situation of the surroundings in the nature of the surrounding, which changes may change time to time. Okay, with this, I have finished the introductory chapter of the power plant engineering. Next day, I will go for the cycle or load factors like this. Those who have came, thanks for your attendance and thanks for patience hearing. Goodbye.